Hi guys, in this video we'll continue to study electrocyclic reaction. In our last classes we have seen definition of electrocyclic reaction, properties, and then selection rule. We'll quickly revise these things and then we'll move further. Definition of electrocyclic reaction means electrocyclic reactions are intramolecular reaction in which a new sigma bond formed between ends of conjugated phi system. Properties, these are intramolecular reaction, these are one step reactions, and the third property is here one new sigma bond will be formed. Fourth property here is product containing one less pi bond compared with reactant. And then selection rule, you know that 4n pi system will be there, 4n plus 2 pi system will be there, thermal condition will be there, and photochemical condition will be there. 4n phi and thermal condition means non-rotatory. 4n plus 2 phi and thermal condition means it is a disrotatory. 4n pi and photochemical condition means disrotatory. 4n plus 2 phi and photochemical condition means it is conrotatory. So remembering these things is very important. Types of pericyclic reaction. First one is the ring closing reaction and the second one is the ring opening reaction. In our last classes we have seen ring closing reaction. Today we will study this ring opening reaction. Ring opening reaction. Consider this example. There is the 1 pi bond here. We have to add one more pi bond to this. So it will be 2 pi bonds, means 4 pi electron system, and the condition is thermal, means it is a conrotatory. You might be surprised why I added one pi bond here. Why this is so means this sigma bond will be formed by the utilization of pi bond. So because of that thing we are adding one pi bond. Here also one pi bond is there. We have to add one more pi bond to this. Here also there is a one pi bond is there. For this we have to add one more pi bond. Here also one pi bond is there. For this we have to add one more pi bond. Here two pi bonds are there. We have to add one pi bond to this because this is a sigma bond. This is formed by the utilization of one pi bond. In order to recognize that, we have to add one pi bond here. Here also two pi bonds are there. We have to add one pi bond. I hope you understood why we have to add the pi bond. So this will be shifted here. This will be shifted here. So the basic product is this one. But the challenging thing here is stereochemistry. Conrotatory means moving in same direction, rotating in same direction. In ring closing reaction, these substituents were in a plane, but here, no, these are not in a plane. This wedge indicates that this is above the plane. This dash indicates that below the plane. So when we are moving in this direction, this above the group will come inside. So H I will write and CSIR I will write here. And when we are moving in this direction, this above group goes outside and H comes inside. This is the product. Here it is 2 pi bonds, means 4 pi electrons, plus photochemical condition means you have to do the disrotatory here. First we'll write the basic product by shifting this here and this here. This is the basic product. Now we have to write the stereochemistry. Disrotatory, you know that shifting, rotating inside or rotating outside, but we consider this here. So if you are moving or rotating in this direction, hydrogen goes inside and CS3 comes outside. If we are rotating in this direction, CS3 comes inside and H goes outside. This is the product. Consider the second example here. And there are 2 pi bonds here. 2 pi bonds means 4 pi electron system plus thermal condition. You know that you have to do the conrotatory. Before that, we'll write the basic product. this will shift here. So now we have to decide a stereochemistry counter means moving in one direction. The hydrogen is above here. If we rotate in this direction, it will come inside and CS3 come outside. So here CS3 is above. If we are moving in this direction, CS3 goes outside and H come inside. Here also there is it. So this is the product. Here there is a 1 pi bond. We have to add 1 pi bond. So 2 pi bond will be there. Means 4 pi electron system plus photochemical condition means you know that you have to do the disrotatory. First we have to write the basic product. Shift this here and shift this here. Write the basic product. And then we have to decide a stereochemistry by disrotation. Disrotation means moving either inside or moving outside. So hydrogen is above. If you are moving in this direction means hydrogen goes inside and CS3 come outside. So you are moving in this direction now. The above group comes inside CS3 and this is H. This is the product. Next we shall see is third example. Here 2 pi bonds are there and we have to make 1 pi bond addition to this. So totally 3 pi bonds will be there. 3 pi bond means you know that it is a 6 pi electron. 6 pi means 4n plus 2 pi system and condition is thermal. So if this is the thing means disrotatory we have to do. First we'll write the basic product by shifting this here and this here. So this rotation we have to do. We have to shift either inside or outside. So if you are shifting in this like this means the above group will come inside and CS3 go this side. H and CS3 here. And if you are shifting in this direction again H will come inside and CS3 goes outside. So this is the product. Here also it is a 3 pi bond. 3 pi bond means a 6 pi electron plus photochemical condition means you have to do the contrary. First we'll write the basic product. We have to shift this here and this one here and this here. Write the basic product. Now we have to decide the stereochemistry. Counter-rotatory means moving in one direction. So if you are moving like this, hydrogen comes inside and CS3 comes outside. If you are moving in this direction means H comes outside and CS3 comes inside. So this is the product. Next we shall see is some necessary conditions. What is this some necessary condition means? When both the substituents are electron donating and if situation arises both should be inside, then that should not happen, because if they both come inside they create a steric effect. So because of that they made a condition like both CS3 groups should not inside. Both electron donating group, you know that CS3 and CS3 are electron donating group. Any electron donating group both should not come inside. If situation arises you must avoid that. This is the condition. You'll understand when we solve this example. We consider this as a 2 pi present here, 2 pi bonds present here, and you know that it is a 4 pi electron system plus photochemical condition means you know that you have to do disrotatory here. So disrotatory means both moving inside, right? So this group is above and this is the below. If you are first we'll write the basic product. So if you are moving inside means this CS3 goes inside and H come inside. So you are moving in this direction. This above group comes inside and H comes outside. this should not be a product. According to the selection rule, this will be the product, but due to steric effect, due to steric hindrance, this will not be a product. So in this case, selection rules will be silenced, and the product will be something different from this one. This may be one CSR is outside and another CS is inside. So this may be a product, but definitely this is not the product because of steric hindrance. I hope you understood what is the necessary condition. We'll apply the same thing here. Here two pi bonds are there. You have to add one pi bond to this one. So totally three pi bonds will be there. So 6 pi electron system plus thermal condition means you have to do the this rotatory, you have to do this rotatory means you know that first we'll write the basic product here, this will be shifted here, this will be shifted here. So the basic product is here. So this rotatory means you have to do what, either move inside or outside. I'll move inside here. So CS3 is there here. If you are moving inside means CS3 will come inside and H comes outside. Here if you are moving in the inside means this above group comes inside, CS3 will come inside and H. Here also both the groups are coming inside. Look at here, CSC and CS3. And the rule is whatever we did this according to selection rule, but condition, this necessary condition says this is not the product. We must avoid it. Something else will be the product, but this is not the product. The second necessary condition is when one end containing a electron withdrawing group and another end containing a electron donating group, we must move electron withdrawing group inside and electron donating outside. Whatever may be the selection rule says, that selection rule is not applicable here in this case. Electron withdrawing group, this group should come inside and this group should go outside. Even though selection rule is telling reverse to this, that will be silenced here. The rule is electron withdrawing group should come inside and electron donating group should go outside. Look at here, it is a 2 pi bond plus 1 pi bond system. So totally 3 pi bonds will be there. You know that 6 pi electron system. And photochemical condition means you have to do the Kahn rotatory, you have to do. First we'll write the basic product. So Kahn rotatory means one direction. Look at here, CS3 it is above and hydrogen below. If you are moving like this, if you are moving in this direction means CS3 goes inside, H comes outside. If you are moving in this direction, this above group will go outside and H comes inside. But this is according to selection rule. This is according to selection, but this is wrong. I told the selection rule is silenced here. What is the condition says electron withdrawing group should come inside and electron donating group has to go outside. So the product for this one is H. This is the product.